In this video, we'll look at the major components of an aircraft. Although airplanes are designed for a variety of purposes, nearly all of them have the same major components. These common airplane structural components include the fuselage, wings, an empennage, landing gear, and a power plant. The fuselage is the central body of an airplane and is designed to accommodate the crew, passengers, and cargo. It also provides the structural connection for the wings and tail assembly. Many older aircraft designs utilize an open truss structure constructed of wood, steel, or aluminum tubing. The most common types of fuselage structures used in today's aircraft are the monocoque, which is French for single shell, and semi-monocoque designs. We'll talk about these design structures in a later video. Wings are airfoils normally attached to each side of the fuselage and are the main lifting surfaces that support the airplane in flight. There are numerous wing designs, sizes, and shapes used by aircraft manufacturers. Each design fulfills a certain need with respect to the performance required of the airplane. We will discuss how the wing produces lift in a later video all about aerodynamics. Wings may be attached to the top, middle, or lower portion of the fuselage. These designs are referred to as high, mid, or low wing. The number of wings can also vary. Airplanes with a single set of wings are referred to as monoplanes, while those with two sets are called biplanes. Many high-wing airplanes have external braces or wing struts which help to spread the loading to the fuselage for additional support. Since wing struts are usually attached approximately halfway out on the wing, this type of wing structure is called semi-cantilever. A few high-wing and most low-wing airplanes have what's called full cantilever wing, designed to carry the loads without external struts. The principal structural parts of the wing are spars, ribs, and stringers. These are reinforced by trusses, I-beams, tubing, or other devices, including the skin of the wing. The wing ribs determine the shape and thickness of the wing. In most modern airplanes, the fuel tanks are either an integral part of the wing structure or consist of flexible containers mounted inside of the wing. Attached to the rear or trailing edges of the wings are two types of control surfaces referred to as ailerons and flaps. Ailerons extend from about the midpoint of each wing outward to the tip and move in opposite directions to create aerodynamic forces that cause the airplane to roll. Flaps extend outward from the fuselage to near the midpoint of each wing. Flaps are normally flush with the wing surface during cruising flight. When extended, the flaps move simultaneously downward to increase the lifting force of the wing for takeoffs and landings. The empennage includes the entire tail group and consists of the vertical stabilizer, the horizontal stabilizer, the rudder, elevator, and one or more trim tabs. The rudder is attached to the back of the vertical stabilizer. During flight, it is used to move the airplane's nose left and right. The elevator, which is attached to the back of the horizontal stabilizer, is used to move the nose of the airplane up and down during flight. The trim tabs are small, movable portions of the trailing edge of the control surface. These movable trim tabs are controlled by the pilot to reduce control pressures during flight. Trim tabs may be installed on the ailerons, rudder, or elevator. A second type of empennage design does not require an elevator. Instead, it incorporates a one-piece horizontal stabilizer that pivots from a central hinge. This type of design is called a stabilator and is moved using the control wheel just as the elevator is moved. For example, when a pilot pulls back on the control wheel, the stabilator pivots so the trailing edge moves up. This causes the nose of the airplane to move up. Instead of a trim tab, stabilators have an anti-servo tab extending across their trailing edge. The anti-servo tab moves in the same direction as the trailing edge of the stabilator and helps make the stabilator less sensitive. the anti-servo tab also functions as a trim tab to relieve control pressures and helps maintain the stabilator in the desired position. The landing gear is the principal support of the airplane when operating on the ground, taking off, or landing. The most common type of landing gear consists of wheels, but airplanes can also be equipped with floats for water operations or skis for landing on snow. The landing gear consists of 3 wheels, 2 main wheels, and a third wheel positioned at either the front or rear of the airplane. A landing gear configuration with a rear-mounted wheel is called a conventional landing gear. Airplanes with conventional landing gear are sometimes referred to as tailwheel or taildragger airplanes. When the third wheel is located on the nose, it's called a nose wheel, and the design is referred to as a tricycle gear. A steerable nose wheel or tail wheel allows the airplane to be controlled while on the ground. Most aircraft are steered by moving the rudder pedals, whether nose wheel or tail wheel. The power plant usually includes both the engine and the propeller. The primary function of the engine is to provide power to turn the propeller. It also generates electrical power, provides a vacuum source for some flight instruments, and in most single-engine aircraft provides a source of heat for the pilot and passengers. The engine is either covered by a cowling or a nacelle. The purpose of the cowling or nacelle is to streamline the flow of air around the engine and to help cool the engine by ducting air around the cylinders. The propeller, mounted on the front of the engine, translates the rotating force of the engine into thrust. As you will recall from the previous video, thrust is a forward-acting aerodynamic force that helps move the airplane through the air. The propeller may also be mounted on the rear of the engine, which is called a pusher-type aircraft. A propeller is a rotating airfoil that produces thrust through aerodynamic action. A low-pressure area is formed at the back of the propeller's airfoil, and a high pressure is produced at the face of the propeller, similar to the way lift is generated by an airfoil used as a lifting surface or wing. This pressure differential pulls air through the propeller, which in turn pulls the airplane forward. Propellers are usually matched to a specific aircraft and power plant combination to achieve the best efficiency at a particular power setting, and they pull or push depending on how the engine is mounted.